Hey, seventh grade. Today our review is on scale drawings, which also involves ratios and sometimes percents. So it's a good skill to review for EOGs. Look at question number 1. Sarah uses a scale of 1 centimeter to 12 meters to draw a floor plan of a new store. She has to redraw the drawing so that it is larger for her presentation. Could Sarah use the following scales? Select yes or no for each scale. So her original scale is 1 centimeter to 12 meters. So for it to appear larger, that means that we want our denominator to actually be smaller. It's kind of like zooming into something. So we're looking for when our denominator becomes smaller, or our fraction basically becomes bigger in a way. So 1 centimeter to 8 would definitely be a yes. Okay, that's going to make it appear larger. 1 to 20 though, 1 to 20 is going to be an even smaller fraction. So that means that the drawing is going to appear even more zoomed out. So that one's going to be a no. 2 to 12. This one's kind of interesting because if we simplify 2 over 24, we're going to get the same. It's equivalent to 1 over 12. So this one would actually appear to be the same. So that one is also a no. Okay, the next one is 3 to 15, which we need to simplify. So 3 over 15 is the same as 1 over 5, 1/5. So that one, kind of like letter A, is going to appear to be larger because our fraction denominator has gotten smaller. So 1/5 is also a yes. Okay, the second question is actually a little more than compared to what we've done in the past with our scale drawings. I think you're going to find this one a little easier. Gregory draws a scale drawing of his room. The scale that he uses is 1 centimeter to 4 feet. On his drawing, the room is 3 centimeters long. Which equation can be used to find the actual length of Gregory's room? So we were first setting up proportions. We talked about WKU. Words known and unknown. So we can definitely do that for this one. We can do centimeters to feet, and we know that 1 centimeter is equivalent to 4 feet, and we are trying to figure out how much it would be for 3 centimeters. So you have to remember that if you put centimeters on top, centimeters has to stay on top of your proportion. And there's our X. So do you see which one this automatically matches with? Okay, if you're thinking C, you are on the right track. All right, there's a couple of questions in between this, but I wanted to skip down to question number 6, the last one. So it's a little different and involves a percent. A science museum has a scale model of a beetle. The scale factor is 5,000%. The length of the model is 1 meter. How long is the actual beetle in millimeters? So remember, whenever we take a percent and we're trying to use it in a scale, remember, even if the percent is huge, we still do those 2 hops over to change it into a decimal form. So this is equivalent to 50.00, or in other words, it's 50 times larger than the original. So we can use that to set up a little proportion. So if it's a 50 to 1 relationship, we're trying to figure out if our original is 1 meter, what would it be as an actual beetle or in real life? So we can use the cross multiplication that we've used for most scale drawings. So 50 times x equals 1 times 1, which of course is 1. Okay, so we divide both sides by 50. And we'll get basically 1/50th, or as a decimal, that's the same as 0.02, and that's in meters. If it's looking for millimeters, though, remember that 1 meter is equal to 1,000 millimeters. So all I need to do to get my final solution is, think if you know. Okay, if you were thinking to multiply by 1,000 to change it to millimeters, you are on the right track. Most of these questions will be calculator active, if that helps you feel a little better. But remember, timesing by 1,000 means that we basically move our decimal over 3 hops. 1, 2, 3. Fill in that missing 0 there. So it's going to be 20 millimeters. All right, that one's a little bit more challenging. Don't be intimidated. Try the other ones and play that way ground game to review for EOGs.